Hello and welcome to our second class on atomic structure. And we will be doing today Bohr's atomic theory. Last time we discussed about the atomic spectroscopy, absorption, emission spectrum. And in emission, we had two types. One is the line spectrum, discontinuous spectrum consisting of a few lines. Those are the spectra of individual elements. And the other one is the continuous spectrum. That the classic example of continuous spectrum is solar spectrum or blackbody radiation, which we have not yet discussed, or an incandescent filament lamp. That also may be a narrow range of radiations, but still continuous. But sodium spectrum, can anyone remind me? Sodium spectrum is popularly called which lines? Yes, Arun. Sodium or sodium, when you take it in a hot condition, in a flame, and it will radiate yellow line. And if you pass through a prism and catch hold of the individual frequencies, individual waves in a screen, what lines we get, Prabhu?
So so
Yes.
D1 and D2 lines.
Yes, D1 and D2 lines. Similarly, potassium has a few lines in the lilac or violet region. Every element will give you a different non-superimposable set of lines. And that is the characteristic unique property of that element. It's called the fingerprint of that element. So, basing on the quantum theory that Arohan was asking a question that he was not able to conceive properly how electromagnetic waves have dual nature. They are waves as well as they are particles. Now, these are massless particles. These are massless. When I say massless, I mean the rest mass. Rest mass means supposing you think that you are asking a photon to stop. Hey, photon, stop. Don't travel with the velocity of 3 times 10 to the power 8 meter per second. Stop. And then you weigh that photon with a balance, in a balance. However sophisticated balance it may be, you will find zero mass. But such a thing will not arise. A photon will not stop. It will always travel with very high speed, to which no one can compete. It is the highest ever speed that is achieved, that is electromagnetic waves. So it is showing wave properties. It is also showing discontinuous nature, that it doesn't move or come out of the source or being absorbed in a continuous manner, rather in single discrete photons, energy packets. And each packet of energy has a charge, has a value which is proportional to the frequency, and the proportionality constant is h, E is equal to h nu. And we correlated E is equal to h nu by, hc by lambda or hc nu bar. Subsequently, you will know how the discontinuity was proved by hydrogen spectrum. Today we shall be studying, and by blackbody radiation and by photoelectric effect. These three you will be knowing, so that you will have an idea that it cannot be continuous like solar spectrum. It has to be discontinuous. Electromagnetic radiations, they contain discrete energy pockets called photons. So to start today, we take up demerits of Rutherford's model. Rutherford was the first person to give some acceptable, logical model of atom. And that an atom consists of a very tiny portion called nucleus, and the electrons are moving in circular orbits. Only that much. And this carries all positive charge and almost all mass. And this is called the nucleus. And these are the extra nuclear parts which are, he didn't tell about circular. He told just it is moving like planets move. Circular word he didn't mention, that just like planets move around the sun, similarly electrons move around the nucleus. Therefore, he gave the name of these electrons as planetary electrons, just like planets. And then there was a lot of criticism, particularly the physicists. They said it is violating law of electrodynamics, that when a positive charge, static positive charge, and around it a negative charge will really rotate, try to do the experiment, then it will definitely be attracted and its energy will be lowered, and it will gradually draw nearer and nearer with a spiral path, and finally will be merged onto the nucleus. So that is the law of electrodynamics. So a moving particle being attracted by another static charge will not remain with the same orbit. It will be drawn closer and closer and closer and closer till it merges. Such a thing doesn't happen. So people challenged Professor Rutherford, why, what is going on? How it is not, in agreement with the theories of physics. Rutherford was silent. He didn't know the answer. The second important violation is hydrogen spectra. Then Balmer came forward with his series. First line in the orange region, then second line in the blue region, and then after that, a few lines uh, in the violet region, they merge. So you get a particular line spectrum. This is called the Balmer series, which showed that the energy levels are fixed. If electron would have acquired any amount of energy, that means there would have been infinite number of orbits. So infinite number of transitions, not 2 to 1, 3 to 1, not like that. Infinite number of transitions from higher energy to lower energy would have resulted infinite number of radiations, and when they fall they will merge into one another, they will overlap with one another, and they will form just like solar spectrum, a continuous spectrum. What is happening in solar spectrum? Why it is continuous? Because it contains infinite number of radiations overlapping with one another. That is why. But here you don't get, in hydrogen spectrum, you get only discrete few lines. Three to four lines are visible. Then after that, no extension. So from the distance, you will say it is a discontinuous or a line spectrum. Such a thing had happened because the energy levels are fixed. Then Bohr came. Bohr said that why the electrodynamics principle is failing is because inside the atom, the world is different. Inside the tiny atom, where the Nucleus has a dimension, has a radius of 10 to the power minus 12 meter, or 10 to the minus 15 meter, I'm sorry, 10 to the minus 15 meter. Such a tiny, and the radius of the atom is nearly 10 to the minus 10 meter. So such a tiny particle, atom, inside that, the theories which is applicable for the macroscopic world. Macroscopic means which you can see in your eyes. So those electrodynamics principle that is applicable in the macroscopic world can perform the experiment in a laboratory, you see that it is happening. But inside the atom, the world is different. It is called the microscopic world. Microscopic world, or they call quantum world. There, those theories will not work. A new set of theories will be operational. That theory is the quantum theory. Quantum theory is only applicable for microscopic world inside an atom. Outside an atom, in the macroscopic world, whatever theories that we have learned will be valid. But inside the atom, a different set of principles will be valid. That is called quantum theory. So Bohr was the first person to use Planck's quantum theory in developing his atomic model. So he postulated, so I'll be giving you all the lecture notes. So about atom, he postulated number one, fixed circular orbits. Fixed. This word is very, very important. Circular is important. Energy is fixed. So that fixed nature is called quantized. The English that is used for anything which is fixed is called quantized. The energy levels are quantized. You cannot have infinite number of energy levels. No. Nucleus is there. Supposing hydrogen atom, only a proton constitutes the nucleus, and after some distance you will find a circular orbit, that is K cell, the first cell. N is equal to 1. The principal quantum number is equal to 1. And after a long distance, after that, you get second cell, L cell, N is equal to 2. And after a long distance, when the radius becomes much greater, it is the third cell, M cell, N is equal to 3. So the electrons, as long as they move in a particular orbit, it does not lose energy. That is the quantum world. It doesn't, yet it doesn't become tired. ये थकते नहीं. It electron continuously move, but without losing any energy or gaining any energy. जब तक रहेगा चांद और सूरज, आई मीन जब तक एक ऑर्बिट में वो रोटेट करता रहेगा, तब तक कोई एनर्जी लॉस नहीं होगा, कोई एनर्जी गेन नहीं होगा. लेकिन इलेक्ट्रॉन कैन जंप फ्रॉम वन ऑर्बिट टू द अदर ऑर्बिट, not from K cell down. K cell is the Lakshman Rekha, is the ultimate energy level, the lowest energy level below which there is no permission of electron to go further nearer to the nucleus. That is the nearest approach of the electron towards the nucleus, that is the K cell. But it can jump to L cell if you supply energy. Then by taking up the required amount of energy, which is the difference between the two, this is delta E. Or if you want that the electron in the K cell will straightway jump to the third cell, bypassing the second cell, then you calculate what is the energy difference between third cell and first cell, and you give that much of energy by way of a single photon, then it will jump. So these are, let me tell you, the this n is equal to 1 is called the ground state. And this n is equal to 1 is called ground state. And I'm talking of hydrogen atom. He developed the theory for hydrogen atom or similar atoms. And n is equal to 2 is the second cell is called the first excited state. N is equal to 3 is called the second excited state. Third cell, but second excited state. And so on. And so on. So most of the time, the electron, the solitary electron will remain in the ground state. But the moment it gains energy from outside source, you provide energy, appropriate energy, then it will jump. If you have given less energy than this, the minimum jumping process is from the K cell to L cell. If you have given less energy, then it won't take. It will reject. Go, go, go. That photon will go away. It will not respond at all. That is what is the interesting thing. However intense beam you may use, intensity is more means the number of photons that is coming out per second is more. If for 1 second a source is emitting 1000 photons, that is a more intense beam, more intense light than if it is emitting, say, 900 photons per second or 500 photons per second or even less. That will look like brighter, less brighter, dimmer, dimmer, and dimmer. But how much energy it has? You can increase the intensity to any high value, but electron will never ever jump from K cell to L cell until and unless you have the required amount of energy, and that you convert it to what is its frequency or what is its wavelength by using that Planck's quantum theory. That photon you have to, that radiation you have to use. You may use more intense. If you use more intense radiation, in agreement with the energy requirement, then more number of atoms will be attacked. One photon will make one electron to jump from K to L. In another atom, another. The third atom, so there will be hundreds and thousands of atoms in a sample. All of them will be affected, will be involved in the jumping process. If you make the intensity high, more number of photons are coming, but each photon should have the adequate energy to carry out the process. If it doesn't, then it will pass through the atom, the no jumping. So electron can jump from one lower cell to the higher cell by absorbing required amount of energy. And in the excited state, its lifetime is very small, in the order of some microsecond, 10 to the minus 5. We will be knowing about that to calculate what is the lifetime of electron in excited states. Very, very small. It has to come back. We shall be studying the principle to know why the lifetime in the excited state is very, very small. वो चला गया ऊपर, लेकिन ऊपर टिक नहीं पाएगा, वो टिक नहीं पाएगा, वो उसको वापस आना ही है घर. मम्मी मम्मी याद आ जाएगा, मम्मी को याद करके मम्मी इज ग्राउंड स्टेट, इट विल कम बैक. So during return journey, it emits radiations. And when that emitted radiation is analyzed through a prism, you get spectrum. Or through a spectrometer or a photographic plate, we get a different series of lines. So the first postulate is fixed circular orbit, which I have written. Then energy levels are fixed or quantized. No loss or gain of energy in a particular orbit, but it can jump. But electron can jump from lower to higher cell, higher orbit or cell by absorbing energy, appropriate amount of energy, and higher means excited state. And when it returns, it jumps. This jumps word is a very lower level term. Instead of saying jumps from lower cell to higher cell, we must say when excited from lower level to the higher level, then it has to absorb energy. When it jumps back from higher level to lower level, rather we say when it is de-excited. When it is de-excited from different higher excited state to lower excited states, or even finally to the ground state, it emits energy. Jumps from higher to lower. It emits energy. And the most important one is this energy absorption and emission take place in single photon. As a single photon, that is given by the Planck's quantum theory, E is equal to, now you write delta E. The only difference you make here, because we have to find out the energy difference between 1 to 2 or 1 to 3 or 2 to 3 or 1 to 5. So we write del E is equal to h nu hc by lambda or hc nu bar, where del E is equal to E n2 minus E n1. N2 is any higher cell. N2 is the principal quantum number or the cell number. That is called principal quantum number of any higher cell. And N1 is the principal quantum number of any lower cell. So we'll be calculating after a bit. So that means del E, which is equal to E n2 minus E n1, and that should be equal to h nu. This is the nu of that single Rasagulla, I mean photon, the hypothetical Rasagulla containing energy, or that lambda is that the wavelength of that Rasagulla, single Rasagulla that it will absorb or it will vomit. This is the wave number of this single Rasagulla. So we will be doing solving a lot of problems now, and the last one is not last but one is about the angular momentum. The angular momentum is also fixed of electron. Is fixed means it is quantized. You know, any particle moving in a rectilinear motion has a linear momentum which is equal to mass into velocity, and any particle moving with a circular motion will have an angular momentum, and angular momentum is expressed as mass into velocity into radius of the circular uh, path, orbit in which it is rotating. So mvr, only one r will be multiplied extra, and he presumed, it is simply his postulate, no rationale or logic, which will be found out in quantum mechanics, wave mechanics. In the coming class, we'll be starting wave mechanics. He wanted something to propose or to presume so that he will have his good mathematical evolution, mathematical deduction to get an energy equation. He was not able to fit the observed frequency of Balmer series with some theoretical mathematical equation. He was lacking something. Then he found that if I can presume this, then every mathematics will be perfect and my equation will be exactly matching with the experimental lines at that time developed or found by Balmer in the visible region. So MBR he proposed should be a whole number multiple of a constant h by 2 pi, and this is n. N can be equal to 1, 2, 3. Principal quantum numbers always starts from 1. The K cell, the L cell, the M cell, and so on. So in the first orbit, the angular moment of electron is simply h by 2 pi. In the second orbit, 2h by 2 pi. Third orbit, 3h by 2 pi. In this way, the angular momentum of electron is quantized. And interestingly, h by 2 pi has a very short notation, h cross. So in many places, you will find h by 2 pi is not written. Simply a cross. I mean, this line is given. This is called h cross. That means h cross. That means h by 2 pi. Planck's constant by 2 pi. So this is the last but one postulate, and the last postulate was, it was not a postulate, but the expression of energy value. The energy of electron at any orbit, not merely the ground state where electron loves to remain happy, contented, unless somebody wants that electron to jump by providing energy. So that is equal to minus some constant k z square by n square, where z is the atomic number or the nuclear charge, the number of protons present. And n is the principal quantum number, a 1, 2, 3, 4 principal, as I have already told you, principal quantum number 1, 2, 3, 4, and so on. The k is a constant, let me tell you, because we'll be solving problems 2.18 times 10 to the power minus 18 joule per atom. It's not joule second, it's not H. Planck's constant is joule second or erg second. This is joule per atom. Energy is in joule per atom, not per mole. पर मोल के लिए आपको एवोगाड्रोस कांस्टेंट को मल्टीप्लाई करना पड़ेगा, और इन CGS 2.18 टाइम्स 10 to the minus 11 erg per atom, or in terms of electron volt it is 13.6 electron volt per atom. And let me remind you, 1 electron volt is equal to the same magnitude, is same as the charge of 1 electron or 1 proton, 1.602 times 10 to the minus 19 joule. That is the conversion between electron volt and joule. 1.602 times 10 to the power negative 19 joules. So just now we shall be deriving how this equation was, and why Z? Because Bohr's theory was applicable for all one electron species. One electron species, not multi-electron species like hydrogen, like helium plus, not helium. Helium has 2 electrons. If you remove the first electron, then it is left with a positive ion, monopositive ion, and the Bohr's theory is applicable for that. And if you are handling lithium, it is Li double plus. Lithium has 3 electrons, and you have to remove the first and second, leaving behind 1 electron. Then it will agree to the Bohr's theory. If you are handling beryllium, it will be 3 plus, and so on. So these are called 1 electron species or hydrogen-like species. to which Bohr's theory is applicable. That is why it is Z is there. If it is hydrogen, Z is equal to 1. If it is He plus, Z is equal to 2 with a nuclear charge. Electron is 1, but this is nuclear charge. पेट में कितना protons है? कितने protons हैं? 2. 2 square means it will be 4. If it is Li double plus, then it will be 3 square, 9. It will be beryllium 3 plus, it will be beryllium 3 plus, it will be 3 square, 9. Oh, it is lithium 2 plus. Oh, sorry. Beryllium is 4. 4 square is 16. Lithium 3 protons, so 3 square 9. Helium 2 square 4. And hydrogen 1 square 1. So that is why the Z factor is there. Z is the nuclear charge, that atomic number. Now, before we take off the derivation, let us take off a question. Say we'll find out the wavelength of radiation absorbed by electron to jump from the ground state, I will write GS, to the first excited state. First excited state means n is equal to 2. Ground state means n is equal to 1. So level 1 K सेल से L सेल को जंप करने के लिए जो फोटोन चाहिए इसका वेवलेंथ कितना? To which region does it belong? हम तो जानते हैं there are 8 regions starting from cosmic to radio waves. To which region does it belong? Now, it's very simple. We'll be solving in K method. E1 is equal to minus K Z square by N square. N is equal to 1. Z is equal to 1 because we are dealing hydrogen atom. I've written for hydrogen atom. कहाँ है? Oh, I've forgotten. In hydrogen atom. Write down in hydrogen. You have to specify which one electron species you are dealing with. It is hydrogen or He plus or Li double plus or B triple plus. I am now talking of H, not H plus, H. So Z is equal to 1 and 1 means the first cell का energy कितना? Simply minus K. And अगर ये second cell को जाएगा, it will be E2, it will be minus K. So this is 1 always, this is 2 square. So this will be minus K by 4. Then what is the energy difference? Delta E is always the difference. To make the difference positive, you have to subtract the energy of the higher cell minus energy of the lower cell, not the other way. Difference is always positive. But after some time, I'll tell you why the energy of the electron is given a negative sign. Why it is negative? I will tell you after some time what makes the energy to acquire a negative value. But the difference is always positive. Higher minus lower. So it is minus K by 4 minus K. LCM is 4, so it will be 3K by 4. And we apply the third postulate, del E is equal to Hc by lambda, because I have asked you to find lambda. So 3K by 4 is equal to Hc by lambda. So then lambda is equal to 4 Hc by 3K. We know all the values. 4, supposing we want in CGS or in SI, 6.626 into 10 to the minus 34 joule into second. C is 3 into 10 to the power 8 meter per second. And K is equal to, just now I told you, 2.18 into 10 to the minus 18 joule. So everything will cancel, only meter will remain. You calculate this, I leave you some time. Then we will convert it into angstrom and tally with our table to know to which region of the spectrum does it belong? Use a calculator or your mobile phone's calculator or anybody else's mobile phone to get me what is the value. Hello, those who are watching in the YouTube, make it a point. If you really benefit, you try to follow my classes and solve some problems at your leisure. I don't say to sacrifice your vital school period or coaching period, but at some time, if you do not revise it and solve some problems, you will be feeling yourself really embarrassed to join further classes. So कितना आया प्रभु? आरोहण. Arohan, the English is ascension.
5 into 10 to the power minus 9.
Huh?
Sir, 1.215 into 10 to the power minus 9.
-5.
9, sir.
-9.
Yes, sir.
ମତେ ତ ଲାଗୁଛି ଟିକେ ଭୁଲ ଅଛି.
Sir, more values say 5.77 into 10 to the power minus 7.
ସେ ବି ଭୁଲ. ସେ ବି ଭୁଲ. So I'm very sad that the calculation has become wrong. Try again. This should come something like this, so that when you convert to angstrom, 1 meter is equal to 10 to the 10 angstrom. So, oh, no. It will be, no. It will be, sorry. It will be 6. So when we multiply, it will be left. Oh, no. Sorry, no. It will be 7. So we'll be left with 10 to the power 3. So this will be 1215 angstrom. This is the right thing. Anybody who has corrected this to 10 to the power minus 7?
Yes, sir.
Prabhu?
Yes, sir.
So why did you say something different? This
Sir,
is
point 1 0.215 into 10 to the minus 7 is, is it correct?
1.215 no 168 whatever, but 1.2 something something times 10 to the minus 7 hey chita.
Yes, sir. Yes, sir.
So ultimately, when this is meter, because we are all using the SI unit, so it will come as meter, and we convert it to angstrom. This will be this angstrom, and then we convert it to you remove the decimal point. It will be 1215 angstrom. So in which region does it fall? Look to your table, which we wrote last time. To which region does it fall? Yes.
Sir,
Sir,
UV rays.
ultraviolet rays.
Yes, UV, ultraviolet region does it. And you know that it is nothing but the first line in the Lyman series. All the lines will fall in the UV region. This is the first line. The transition is from n is equal to 2 to n is equal to 1. I mean, of course, these are emission spectrum, but we are calculating for absorption. Same thing will happen. Supposing it will remain for some time in the excited state, in the first excited state. I told you its lifetime is extremely small. It has to return back. And from this second cell, there is no other cell to return back than to the Lakshman Rekha K cell. So the same, it will carry the same photon inside its tummy. It will not digest. The electron doesn't have a digestive system. It will carry the same rasagulla. It will not enter into its small intestine, then large intestine. Not any digestive system is present. It will remain in the stomach. And whenever it will come, return back, it has to return. It cannot stay for long in any excited state. It will carry the same rasagulla in the tummy, and when it will return to its mommy's place, it will vomit out the same rasagulla. So the first line will be in the invisible region, that is UV region 1215 angstrom. And you will calculate the second line, that is a home task, that you will find hydrogen atom. I am giving this in a telegraphic language. N is equal to, I am just giving it in the proper emission manner. N is equal to 3 to n is equal to 1. That means it is already in the second excited state. N is equal to 3 means it is in the second excited state. Somebody has already elevated by putting a bigger rasagulla, that the electron has jumped from the K cell or the ground state to the third cell, that is the second excited state. And now I am asking, the rasgulla it is carrying inside its tummy, undigested. It will be vomited out. So what is that tummy? What is that photon which will be coming out? What is its frequency? And to which region does it belong? You will find the same UV region, and it will be some 1000 something, like 1025. You have to find out, calculate. This is a home task. This is the second line of the Bohr series. The first line, this is the second line. This is from 2 to 1. This is n is equal to 3 to 1. And you will calculate later from 4 to 1. It will also come in the ultraviolet region. It will be about 900 something. And after few lines, then you'll find the change will be in the decimal point. 931.5, then 931.47. It will decrease, no doubt, but in the second place, third place, fourth place, then it will appear as if they are merging onto one another to form a thin band. This thin band at which or beyond which you don't find any lines. The lines converge because their transition energy or photon energy value, the corresponding lambda, they are very, very close, overlapping. So this thin band is called a continuum. But overall, it is the Lyman series is a discontinuous spectrum. It is a line spectrum. Now, I will give you another question to solve it here. Now, Balmer series will be in the visible region. I told you the Balmer was the first man, Balmer. He was the first person to record the discontinuous hydrogen spectrum in the visible region. One in the orange region, the first line, the second one in the blue line, third one in the violet region, and then same violet region there will be continuum. So all these transition will be from n is equal to 2, higher cell to second cell. It has gone to 4, 5 or 6 or 7 or 8 or 9 and 10. It will coming to 2, directly to 2, from 4 to 2, 5 to 2, 3 to 2, 7 to 2, 9 to 2. All possibilities happen. Some are transiting from higher cell to first cell directly. Some will be transiting from different higher cell to second cell. Some others will be transiting from different higher cells to third cell. That is the Paston series. So when I say question is like this, find the lambda for the first line of the Balmer series of hydrogen atom. So now tell me n is equal to what to what? The transition between which n value to which n value? Yes? Just like in the Lyman series, the first line was from 2 to 1. 1 is the destination. For every line in the Lyman series, the destination is the first cell, the ground state. But for every line in the Balmer series, the destination cell is the second cell. Although second cell is not the ground state, lekin second cell is the destination cell. So tell me the first line of the Balmer series is the due to the transition of electron from which cell to which cell? Arohan?
Sir, shell 3 to 2.
Yeah, it is from n is equal to 3 to n is equal to 2. And the second line will be n is equal, this is the first line. And n is equal to 4 to n is equal to same 2 is the second line. And so on. So calculate that using the K method. So the second cell is equal to minus K Z square, since it is hydrogen, is equal to minus K by 2 square is equal to 4. And it is coming from third cell, E3 is equal to minus K by 3 square is equal to minus K by 9. So the difference is equal to E3 minus E2 minus K by 9 minus K by 4. So the LCM is 36 and this will be 5K by 36. So this is equal to hc by lambda according to Planck's quantum theory. According to the postulate of Bohr, using Planck's quantum theory as one of the postulates. So 5K by 36 is equal to hc by lambda. So you find out this way. At this time, don't give me a wrong value. Lambda will be equal to 36 hc by 5K. 36, 6.626. So some meter you will get, and then convert that into angstrom and tell me what is the angstrom value finally. Hello, those who are watching in the YouTube, and you feel like following my classes, and do it seriously. If not, yes, of course, our classes will be hardcore, concept based, and deep rooted in depth. As well, we will be taking care of NEET examination into our mind and also the IIT advanced. Therefore, in the beginning, in the introductory lecture, I told you last time that you should enjoy learning, not being so concerned or serious about your NEET examination or IIT advanced. So that will be automatic. If you learn well, apply them well, then you will definitely arrive at your target, your destination. So kitna hua? Yes, Prabhu?
Sir, 6565 angstrom.
6560 angstrom.
What? Finally,
Sir,
angstrom mein kitna hua?
6565 angstrom.
6,600?
Sir, 6565.
And which region does it belong?
Sir, in the visible rays.
Yes, already I have told you several times that Balmer series in the visible region. And I have also told you that this is in the orange region. This line is in the orange region. So yes, visible, and that too, this is the orange line. Your calculations, Prabhu, went wrong, Baba. Somewhere down the line.
No, sir, ମୁଁ ତ ଏଇଟା କହୁଥିଲି.
AIG?
Yes, sir.
That then fantastic. Then whatever will happen ultimately when you, oh, I'm so sorry. 10 to the 10. Oh, I'm so sorry. Because this will come in meter. 1 meter is 10 to the 10 angstrom. Had it been centimeter, then 10 to the 8. If it were done in CGS, 10 to the minus 27, 10 to the, this is 10 to the 10, 10 to the minus 27, and this is 10 to the minus 11, all in CGS, then you would have got in centimeter, then multiplied by 10 to the 8 to get into angstrom. But we are getting in meter, so 10 to the 10. Similarly, at home, I give you a task that find for hydrogen atom the transition from n is equal to 4 to n is equal to 2. Which line does it correspond? Which
Sir,
line
second line.
of which series?
Sir, of Balmer series.
So Balmer. Once you find the destination is 2, then irrespective of from which higher cell it is coming, then it belongs to the Balmer cell, and all of the lines will fall in the visible region, but the pattern is same. There will be first line here, second line will be some gap will be quite evident, large gap. The blue region will find it will be about 4,000 something in the blue region, and then in the indigo region one, and finally in the violet region it will go on overlapping. So the pattern is the convergence. The lines will converge towards the wave number, the pattern of each series. The lines will converge towards the lower wavelength region. This is 6,565 angstrom. You will get it. I have given you the task 4,000 something something. And within that, within the same 4,000 something, it will be converging. It will not cross below 4,000. Somewhere you find lines will converge towards the lower wavelength region. So if I ask you a question, what will be the lambda of the Rasgulla, the photon that is emitted or that is absorbed, whatever it may be. If it is absorption spectrum, it is absorbed. Or indirectly, I will ask you, what is the wavelength of the lowest wavelength line? That means when it is merging, overlapping and forming a band called continuum, what is the last line? That means you have to put n2 is equal to infinity. That means it will, that is, find the lambda for the lowest wavelength line in Balmer series. That means from n is equal to infinity to n is equal to 2. That means E infinity is equal to minus k 1 square by infinity square, that is equal to 0. So we take the electron has no energy, has 0 energy, while it is outside the electrical field of the nucleus. That is called the infinite distance. Infinite distance is not really America or Russia. It is a place where the electron has no attraction. It is away from the electrical field produced by the nucleus. So at infinite distance, formula पकेले 0 आसुची, and E2 is equal to minus k by 4. So delta E is equal to minus E infinity minus E2, that is 0 minus k by 4. It is simply k by 4. So you can find out k by 4 is equal to hc by lambda. So what is lambda? That will be coming, I will think 4,000 something something. And that is the lowest wavelength line that will be merging, the last part of merging. That line will be coming. You also do at homework. If you get time, it will be 4,000 something angstrom. It is the lowest wavelength. The highest wavelength line is the first line. The lowest wavelength line when you take in higher n is equal to infinity. N2 as infinity, N1 is 2. Whenever you are dealing with the Balmer series, the lower cell is 2. If it is 1, then it is Lyman series. Similarly, let me draw the energy profile so that you can understand. For hydrogen atom, the first n is equal to 1, the energy is minus k. The absolute energy is minus k. And if n is equal to 2, this is the energy profile. It is minus k by 4. N is equal to 3, the absolute energy is minus k by 9. It is n is equal to 4, it is minus k by 16. N is equal to 5 and so on. Minus k by 25. N is equal to 6, minus k by 36. So all transitions from 2 to 1, 3 to 1, 4 to 1, 5 to 1, all culminating, you will find the energy difference, although will be more and more. But the energy difference, that is called the transition energy, will be coming closer and closer, will be becoming coming closer and closer. Because as you go to higher levels, the transition energy is here, this one, the third to one is not exactly double. It is less than the double. And from 4 to 1, it is not exactly the triple. It will be much, much less than the triple. And so after some lines, the transition energy becomes very, very close to each other. As a result, their corresponding lambda will overlap to form a thin band. This is called the Lyman series. We just write down. Similarly, I am using another caller. So if the destination is 2, from 3 to 2, from 4 to 2, from 5 to 2, 6 to 2, 7 to 2, 8 to 2, infinite to 2, this is the Balmer series. Similarly, if we 3 as the destination, from 4 to 3, 5 to 3, 6 to 3, 7 to 3, this is called the Paschen series, which you will solve problems. Similarly, when you take the destination as 4, that is 5 to 4, 6 to 4, 7 to 4, this series is called the bracket series. Similarly, when you make the destination cell as 5, that means 6 to 5, 7 to 5, 8 to 5. This is called the P-fund or P-fund series. Similarly, when you take 6 as the destination, 7 to 6, 8 to 6, this is the Humphreys series. All these will fall in the IR region. This will fall in the visible region, Balmer series. And this will fall in the UV region. The one series in the UV region, the other series, the second series in the visible region, and all other 4, they will be falling in the IR region. The first Paschen in the beginning part, then the next part is bracket, then the next part is P-bond, and the last part is Humphreys. So far, nobody has discovered any series which is culminating in the 7th cell. 8 to 7, 9 to 7, such a thing has not yet come. You understand? Any question?
Sir, if the destination is 3, then the series is known as?
Paschen.
Okay, sir.
Then it is bracket, BRACKET, bracket. Then P-fund, PFUND.
Okay, sir.
Then Humphreys. Okay. So, I would like to now derivation of energy equation. A simple physics will be involved here. Let us first let us use SI system. This is very important. If somebody is competition minded, maybe IIT Advanced or even NEET, then he or she has to follow the steps, because questions you might get. Supposing this is the nucleus, Z is the atomic number, E is the magnitude of the protonic charge, which is equal to that of, and this is only one electron. This is for the one electron species. Bohr theory is applicable for one electron species, which is in the ground state. Lakshman Rekha, it is moving always until and unless you sort it out by supplying appropriate amount of energy. Now, supposing the radius is r, and as a general principle, if a particle is moving in a circular path, then the centripetal force, that is the force of attraction with which a particle is being attracted towards the center, is always equal to the centrifugal force, the force with which it is trying to go out. So these two opposing forces, they are balancing each other, cancelling each other, so that it is going in a circular path. The tangent drawn at a particular point, that is the direction of the motion at that particular instant. So every time the two forces are cancelling, here the force which is trying to attract towards the center is centripetal. And in this case, in the electrical field, it is the Coulombic force of attraction. In gravitational field, it is gravitational force of attraction. So depending on which field it is in the quantum world, it is in the microscopic world, where the Coulombic force of attraction, that is the centripetal force, Coulombic force of attraction. In class 12, we will be knowing about the static electricity, Coulomb's law. I think we have done, Mr. Prabhu, that Coulomb's law is force between two charges, maybe opposite charges, it is repulsion. Unlike charges, it is attraction. Like charges, it is repulsion. Whatever it may be, the magnitude of the force is equal to a constant K into Q by R square. Q is one charge, small q is another charge. This is the Coulomb's law. And this K, the unit of K is Newton meter square per Coulomb square. This is Coulomb square, because it will come down to the power -2, Newton meter square per Coulomb square. So that is the unit of K. And in SI, K has a value, is 1 by 4 pi epsilon naught. Usually we take naught because it is in air or in empty space, which is nearly same value. But if change the medium, epsilon will change. So epsilon is the permittivity. And of air or vacuum, whose value is 8.85 times 10 to the power minus 12. Of course, if 1 by 4 pi epsilon, which is equal to K, is Newton meter square per Coulomb square, and epsilon naught is in the denominator. So what will be the unit of epsilon naught? Voltage. It will be Coulomb square per meter square per Newton per meter square. You understood? Because 1 by 4 pi epsilon is K, and the K has a unit Newton meter square per Coulomb square. So if 1 by 4 pi epsilon is this unit, so epsilon will be its reciprocal unit, that is Coulomb square. This is negative, so that will be positive. Coulomb square per Newton per meter square, that is the value of, that is the unit of epsilon. Actually, permittivity is the polarity of the medium, the entire bulk of the medium, which will influence the electrostatic attraction or repulsion between two static charges. If it is air, it will have certain value. If it is inside water, you are putting two charges, then the attraction will be controlled by the medium water. If it is between glass, one charge is the other side of the glass, another charge is in the other side of the glass, so the medium is glass, then epsilon will be different. So that is the bulk polarity of the medium called permittivity, and it is related to the relative permittivity, which is called the dielectric constant, which is uh, epsilon of any medium by epsilon of air, that is not, is equal to called dielectric constant, E, or say epsilon relative. This is called dielectric constant. In case of water, it is 80. That means water has 80 times more permittivity than air. So that is having no unit. But the absolute permittivity has a unit, particularly in the electric field. It is Newton meter square, Coulomb square per Newton per meter square. So different medium plural is media. This is dielectric constant, or otherwise called relative permittivity, which is a number. We will not discuss more about this permittivity. So this K constant value, the proportionality constant, the force is directly proportional to this charge, that charge, and inversely proportional to the square of the distance between the two charges. So then the proportionality constant is K, and in SI, the K is 1 by 4 pi epsilon. But since we are using the medium as air or vacuum, then we are writing epsilon naught, whose value is this. And in CGS, K is equal to 1. That's interesting. K value is equal to 1. So force is in dyne, and charge is in start coulomb, or formally called electrostatic unit, and distance is in centimeter. This is CGS. Force is in dyne, and K value is 1. So let us try to, once again, this is the nucleus, which carries the positive charge Jd, and there is one electron. This is proton. Proton and electron has the same charge. How much? 1.602 10 to SI, 10 to minus 19 coulomb. And in CGS, charge of one electron or one proton is equal to 4.8 into 10 to minus 10 stat coulomb, or ESU. First, we will be doing in SI unit. Then we'll finish our class today and apply next time. So let us derive in SI unit. Centrifugal force is always fixed, whether it is magnetic field, electric field, or gravitational field. It is always, that is mv square by r. It is moving with a mass. Any particle is moving with a mass m, and r is the radius of that circular orbit, v is the velocity. So mv square by r, that is the centrifugal force, which is trying to take it away from it. So they are balancing. This is centrifugal force, this is centripetal force, and in this case it is the Coulombic force of attraction. They are cancelling each other, so it is going in the tangential direction, the direction which is known from the direction of the tangent drawn at that particular point. So every time it is balancing, is going. So direction is always changing, but the magnitude of the velocity is same. And therefore, in the language of physics, we say it is accelerating. But acceleration is only due to change in direction, not change in the speed. Now, this is let us equal. Centripetal force is equal to centrifugal force. So this is 1 by 4 pi epsilon naught, and here JD into E by R square, because one charge is JD. Magnitude is same. Proton and electron have the same magnitude. Z is the nuclear charge. So JD is the nuclear charge, and only one electron is E. So that is equal to, the centrifugal force is equal to mv square by R always. So to write in a converse manner, mv square by R is equal to 1 by 4 pi epsilon naught JD square by R square, where v is the velocity of electron, m is the mass of the electron, which we know 9.1 into 10 to the minus 31 kg. We know mass of the electron in SI. Velocity of the electron we will find out just now. R radius of the orbit we will find out just now. Electronic charge we already know 1.602, or electronic or protonic, same, minus 19 coulomb. These things we know. So let us develop an equation. mv square is equal to 1 R get cancelled. So mv square is equal to 1 by 4 pi epsilon naught ZD square by R. This is equation 1. Then from where we can find out v square is equal to 1 by 4 pi epsilon naught. M is to be brought to the other side, to the denominator, ZD square by MR. Let's say this is equation 2. Now, let us bring in the postulate of Bohr, quantization of angular momentum. What is that postulate? Who can remind me? That mvr is equal to nh by 2 pi, or nh cross. This is the fifth, last but one postulate we discussed before some time. N into h by 2 pi. So the quantization of angular momentum, that postulate made by Bohr, says that mvr, which is the physical expression of angular momentum, is equal to a whole number multiple of h by 2 pi. So from this we can find what is v and v square. So from here v is equal to this much and v square is equal to n square h square by 4 pi square, and this is m square r square. This is equation 3. I made it square. So everywhere square. This is n square h square by 4 pi r square, and this square m square r square. So let us equate this 2 and 3. From 2 and 3, from equation 2 and 3, we get, from equation 2, it is 1 by 4 pi epsilon naught into, it is ZD square by MR. And equation 3, from the quantization of angular momentum, n square h square by 4 pi square m square r square. So 1 m gets cancelled, and 4 get cancelled, 1 pi get cancelled, and 1 m get cancelled, and nothing else. So we can get an equation for radius. Today we'll be closing here. the radius R will bring to one side and the remaining will be kept in the right side. So it will be n square, h square, and what else? 1 pi will be going, 1 m will be going. No. Only R will be going, the other one will remain. So n square, h square, z square will come here. लेफ्ट में और कुछ नहीं है तो राइट को जाएगा, लेफ्ट को जाएगा आर. सो एवरीथिंग विल रिमेन इन दी राइट. एन स्क्वायर एच स्क्वायर भी रहेगा, जेड स्क्वायर नीचे आएगा. सो पाई इज हियर, एम इज हियर. सो इफ यू सेग्रीगेट कांस्टेंट टर्म्स को अगर अलग कर दें हम, दिस इज एच स्क्वायर बाई जेड. नो, जेड इज वेरिएबल, सो it is pi m e square. These are the constant term, and then the variable term n square by z. Z is the atomic number, n is the principal quantum number. देखो सही है, or I have left out something from the derivation. Is it okay?
Yes, sir.
Yes. So if you use the value h is equal to 6.626 into 10 to the minus 34 joule into second, and pi is 3.14, mass of the electron is 9.1 and 10 to the minus 31, all SI, kg, electron or proton, whatever. The charge of one unit is equal to 1.602 times 10 to the minus 19 coulomb. You will find a constant that R of any radius will give a subscript n is equal to, we call it a naught into n square by z. This a naught you will find will be 0.529 into 10 to the minus 10. So this is will coming in meter. So we'll call it, say, in angstrom. So a naught is equal to 0.529 into 10 to the minus 10 meter, or 0.529 angstrom. So finally in angstrom a naught, the constant is in angstrom is 0.529, but in meter it is 0.529 into 10 to the minus 10 meter, because this is equal to 1 angstrom. So finally we can get the radius of any one electron species by using this relation. Supposing I will ask you, what is the radius of the first Bohr's orbit of hydrogen atom? So this will be 1, this will be 1. It is simply a naught, 0.529 angstrom. What will be the radius of the second line of, supposing we will solve a problem here at the last. Find the radius of the second orbit of He plus. He plus, Li2 plus, they belong to this fraternity, one electron species. So what is the radius? So we will use the formula R2, second orbit means R2 is equal to A naught is fixed, 5 to 9 angstrom. N square, it is the second orbit, 2 square, and the He plus iska पेट में 2 protons है, so 2, simply 2, n square by z, not z square, by z. So 2 get cancel this angstrom, so it will be 2 times 0.529 angstrom. It's equal to 1.058 angstrom is the radius of the second orbit of He plus. In this manner, you can find out the radii of any orbit, second orbit, third orbit, fourth orbit, fifth orbit, first orbit of He plus, Li double plus, and B3 plus. So in the midway, we leave energy calculation. We'll be doing next time on to follow. radius, we have gone up to radius, then you have to find the energy equation. That E is equal to minus K, that derivation, what K contains, what are the terms contained. So we'll be deriving, adding up the potential energy and kinetic energy. We'll be doing that in our Tuesday class, that is on, it is falling on 12th. So see you on 12th morning, 4:30. Stay tuned. Bye, and keep your doubts posted on me in your personal WhatsApp or even in Telegram. You can also use Telegram because nobody will be using, rather others will be motivated to see that somebody is asking question. Its Telegram channel is not lying idle, dormant. Make it active by putting some questions or anything. Bye bye.
Pranam, sir.
See you on Tuesday.
Thank you, sir.
Pranam, sir.